live recording here. Okay, we should be recording. Let's double check. Yeah, we're recording. Okay, so y'all, let's do this. Let's continue with our notes from chapter 6. Y'all, I'm going to scroll down here to this next problem dealing with graphing sines and cosines, okay? So let me zoom in, y'all, so we can see this a little bit better. All right, so y'all, it says up here, if we're gonna graph y equals a sine of bx or y equals a cosine of bx, where my number b is gonna be a positive number, okay, so b is gonna be positive. Step number one, y'all, we're gonna find the period of the function. Remember, the period of the function tells me how long does it take to make a complete cycle. So y'all, again, the other day when we were talking about, the daily temperatures and stuff like that, the period of a day would be 24 hours, right? That's how long it takes for a day to make a complete cycle. So, y'all, the way we're going to find the period is we're going to take 2 pi and divide it by b. So, y'all, first thing I'm going to do here, I'm going to look at the equation that we have. We have y equals negative 2 sine of 3x. And, y'all, what I'm trying to compare it to is this guy right here, okay? So number one, if we're going to find our period, we're going to take 2 pi and we're going to divide it by whatever the number b is. In this case, y'all, if we were to do a stare and compare, looking at this guy here and looking at that guy there, what would you say our number b is? Look where the b is. Boom, the b is right here. What do you say our number b is? 3. So our period, y'all, is going to be 2 pi over 3. Okay. In addition, y'all, step number one says we're going to start at 0 on the x-axis, and we're going to lay off a distance of 2 pi over b. In this case, we're going to lay off a distance 2 pi over 3. So, y'all, let me see if I can zoom out a little, because there should be, here we go. I'm going to do it down here, okay? I know it's probably on the next page for you guys, but look, boom. There's 0. Y'all, I'm going to do my 2 pi over 3 kind of at the end. This way I kind of have enough room to do what I need to do. Okay, so look, I just kind of did that. Here's my 0, there's my 2 pi over 3. Let's come back and let's see what else we got. Okay, step number 2, y'all, says divide the interval into 4 parts. Okay, I'm just going to do it here and then we'll come back and we'll fix it in a minute. All right, so look, y'all, here's my x-axis. Okay, here's 0. Here is 2 pi over 3. Y'all, the first thing I want to do, I want to find what's going to be right in the middle. What do you think would be right in the middle between 0 and 2 pi over 3? Y'all, the way we could do this, the easy breezy coverable way we can do this, we're going to add those two numbers together. So if we add 0 and 2 pi over 3, you guys agree we still get 2 pi over 3? Okay, we're going to take half of that. If we take half of that distance, wouldn't we just get pi over 3? That, my friends, is that number right there. Now, again, we're going to cut this into 4 equal parts. So, y'all, the other thing that I want us to find, I want us to find what that number is, and I want us to find what that number is. Okay? So, look, let's do the first one. Let's take 0 and let's add pi over 3 to it. We still get pi over 3. Now, what are we going to do? We're going to take half of that. What's pi over 3 times 1/2? Anyone know? Just multiply straight across. Pi over 6. Boom. Here's that number. Okay. Y'all, we're going to do the same thing over here. We're going to take pi over 3 and we're going to add 2 pi over 3. Y'all, if we take pi over 3 and we add 2 pi over 3, that's going to give us 3 pi over 3 or just pi. What do we got to do with that? We got to find half that distance. Let's multiply it by 1/2. So y'all, pi over 1 times 1/2, wouldn't that give me that number right there being pi over 2? Okay, now my friends, we cut up our number line into those 4 equal pieces, right? Okay, let's take a look at what step number 3 says. says evaluate the function for each of the 5 values resulting from step 2. Okay, let's do this, y'all. We're going to do this. We're going to say, look, we want to know what is the sine of 3x when x is equal to 0, pi over 6, pi over 3, pi over 2, and 2 pi over 3. And y'all, I'm actually going to do it this way. I'm going to do one extra step here. 3x, and I'm going to go sine of 3x. Okay. Y'all, these are going to be our regular pretty numbers that we always use. Okay. So that now, when we're looking for the sine of 3x, we're really asking ourselves, do we remember the sine of 0, the sine of pi over 2, the sine of pi, the sine of 3 pi over 2, and the sine of 2 pi? So remember, y'all, when I'm thinking about the sine function, remember, my friends, I'm thinking about the y values, right? The y values. Okay, here's my unit circle. Okay, this is 0. Y'all remember the point over here? Isn't this point? What's the y value? What was the y value over here? What was the y value over here? What was the y value down there by my twos? And then back to, boom, good. You guys remember, awesome possums. So y'all, we're gonna go like this. We're gonna go 0, 1, 0, negative 1, 0. Okay. Y'all, the only thing is, we're not just looking at a sine of 3x, we're looking at a negative 2 sine of 3x. So look, y'all, boom, we're gonna come back down here. We're gonna put a negative 2 sine of 3x. All right, y'all, the only thing that's different from this line right here, y'all, to that line is we got to take the numbers that we had right here. We got to multiply those numbers by negative 2. Okay. 0 times negative 2, still 0. 1 times negative 2, negative 2. 0, negative 1 times negative 2, positive 2. 0 times negative 2, boom, still 0. Okay. All right. Now, y'all, I'm going to zoom out a little bit more, boom, because this is what we're going to do. We're going to come back over here, and let's see, right in the middle, we had a pi over 3. Right over here, we had a pi over 6. And right here, y'all, we had a pi over 2. Y'all, I want you to look at my y values. My y values are going anywhere between a low value of negative 2 and a high value of positive 2. Okay, boom, let's do this. Okay, so we said at 0, we were at 0. Guys, I'm going to zoom out just again a little bit because I want to see everything. Boom. Oh, come on. Okay, here we go, just to get everything on the same page. Y'all, at pi over 6, we were at negative 2. So down here, I'm going to be at negative 2. We were back to 0. We were back to positive 2. We were back to 0. Boom. And there's my picture. Does that make sense how we're able to kind of go through that and do those things one step at a time? Yo, when we were here on Monday, I kind of showed you a different approach. But yesterday I was trying to figure out, like, man, what's an easier way to sort of explain this? And I like that idea of once we find our period, we're going to start from 0 and we're going to mark where our period ends. And then the first thing we're going to do, we're going to say, okay, what's the number in the middle? Add 0 and whatever that number is, take half of it, boom, that's that number in the middle. To find the first quarter, take 0 and your halfway point, add them together, find half of that. To find the second quarter point, take your middle number and where your period ends, add them together, find half of that. And then we found each of those real pretty numbers. Does that make sense? And then we can go ahead and just find our functions, right? Find our values. Okay. Yo, let's try another one and let's see what we got here. All right. Y'all, example 5 says, let's graph y equals a cosine bx. It says b here is a multiple of pi. Okay, first thing we're going to do, y'all, we're going to look for our period. Okay, so step number 1, y'all, we're going to look for the period of the function. The period is always 2 pi divided by b. Y'all, what I'm thinking of is I'm trying to compare that function to the one that we have, which looks like this. Oops, sorry, not a B, but an X somewhere. Boom. Okay, my question, y'all, anybody know what our number B is here? Remember where B is pi, right? Boom, B is pi. B is the number in front of the X. Okay, look, y'all, we're going to take 2 pi divided by pi. Sorry. So our period is just equal to 2. Okay, step number 2, y'all, look, this is what I'm going to do. I'm going to think about my x-axis. Okay, here's 0. Boom, we're going to go to 2. Y'all, this one's going to be easier for us to cut it in half. What number is right in the middle between 0 and 2? 1. What number is right between 0 and 1? Wouldn't it be 1/2, right? Anybody know what number is right between 1 and 2? 1.5. Isn't 1.5, y'all, the same thing as 3/2? Okay. All right, let's do this, y'all. Look, we're going to make a table. Boom. Come back here. We're going to make a little table. Our table is going to look like this: 0, 1/2, 1, 3/2, and 2. Not 2 pi, or just 2. Boom. Sorry. My next part is going to look like this. See how we have that pi x? I'm going to put a pi x right here. My pi x is just going to be the traditional values where we evaluate our trig functions at. Okay. The third line in my table, my friends, is going to look like this: cosine of pi x. Okay. Just for you guys, I'm going to play the same game we played right now. Okay, remember guys, my cosine is involving my x values, okay? So remember y'all, the point over here to your right, my left hand, but when you're looking at me to your right, this is the point 1, 0. I'm thinking about my x values. What was the x value here at 0? What was the x value over here? 0. What was the x value over here? And it went down here by my toes was. And then that over here again was. Boom. You got it. Take it away. So y'all, we're going to come back over here and we're going to say, look, Omar, that's a 1, that's a 0, that's a -1, that's a 0, and that's a 1. But y'all, look at what we have in front of our cosine. We got a -3. All we're going to do now, y'all, is we're going to take each of those numbers right there. We're going to multiply every single one of them by -3. -3, 0, +3, 0, -3. Okay. I'm going to zoom out just a little bit so we can see everything here. Y'all, on my x-axis, we, my friends, are going to go from 0, all the way out here to 2. That's 1. That's 1/2. That's 3/2. It looks like our graph bounces back between a low number of -3 and a top number of +3. 1, 2, 3. 1, 2, 3. Okay, at 0, we're down here at -3. We come up to 0. We go to +3, back to 0, back down to -3, and boom, there's my picture. That's all you got to do. So y'all, when we were here on Monday, the way I started doing these problems on Mondays, I said, look, let me start here, and then we'd have to go back and find each of those values. Now we're saying, look, let's find those values right away. Why? Because we start at 0, we end at where our period is, we cut that part in half, we cut each of these parts in half, and we found those numbers real easy, breezy, cover girl. I think it's easier. I always did it the other way off. When I learned it, that was how I learned it back in the day, right? But I think this is probably an easier way to do it. Okay, guys, I'm going to scroll down a little further. Okay, what we're going to do here, we're going to be given a graph, and we're going to ask ourselves, can we write the equation based on the picture? So this is what I want us to do real quick. Like, I want us to look at this picture right. Okay, they're telling me it's going to be in one of two formats. This picture is either going to be a sine graph or it's going to be a cosine graph. So I want you, let's do this real quick. Like, boom, let's come back here. Let's take a little snapshot of that picture. Let's go right here. Okay. And let's take a little snapshot of this guy. All right. Oops, sorry. Okay, so guys, what I'm doing is I'm looking at this picture right here, right? Now, I want to ask you, does it look like this picture right here? Or does it look like this picture right here? And I'd say, hey, you know what, Omar, dude, look at that. It looks just like this one, right? Really similar. Okay, so this picture, the one we just did right now, y'all, wasn't that a negative cosine? Okay, so y'all, number one, the cosine graph normally does this. It looks kind of like a bowl, right? This one looks like an anthill. So because it's flipped, we have that negative, right? Because what we did is we kind of flipped it like this. So the first thing is I'm saying, like, look, I'm going to have a negative cosine. Okay, let's see if we can figure out a couple of things. Let's do this. Boom, let's come back over here. Let's see if we can find out some stuff. So right now, my general idea is, look, I'm going to have a negative cosine of some kind of an angle, some kind of x, right? Some kind of theta. I don't know what it is, but we're going to figure that out. Let's do a couple of things, y'all. Number one, let's see, just by looking at the picture, do we know what the period of this thing is? Look, y'all, we start at 0 and we ended all the way where? At 4 pi. So we know that our period is 4 pi. Y'all, the formula for finding the period is 2 pi over b. So the first thing I'm going to do here, y'all, I'm going to think of that 4 pi as 4 pi over 1. And what I really want to try to do, y'all, I really want to try to solve for the letter b. So you guys remember probably back like in 7th, 8th grade, we do a little cross multiply action. So 1 times 2 pi is 2 pi, and 4 pi times b is 4 pi b. And if we decided to get rid of our 4 pi, those would go away. The pi's are going to go away. Y'all, 2 over 4, can't we reduce that to 1/2? Okay, so look, y'all, number one, we know that our b is 1/2. Okay, so now coming up with a couple of things. Right now, y'all, it looks like we have a negative a, whatever that number is going to be, cosine of 1/2 x. Okay, now, y'all, I want to find my amplitude. My amplitude is going to tell me kind of right here from the middle, how far do we go up to get to our high point? Or you can think about it like this, y'all. I draw a line like that, right? How far do I go down to get to my low point? What's the distance, whether I'm going up or going down? How far is it? Remember, this is a y value of 0. We're here at 2. We're here at -2. How far is it from there to there, there to there? Isn't it 2? Okay. But we know we were going to have a negative, y'all, because that thing was flipped. So couldn't we now say that our graph looks like this? A -2 cosine of 1/2 x. And we're done. And all we had to do was do a little stare and compare action right there, right? That's all we're doing. All righty. Y'all, we're going to do, that was 6.3. So y'all, there's another question in here, but I'm going to skip this, y'all, because this problem is asking us to use the graphing calculator. We don't have a graphing calculator here with us. So we're going to skip example 7. And guys, you don't have anything like that in your homework, okay? We have to use the graphing calculator. But again, I just for like your own knowledge, I want you to notice what they're talking about here. They're talking about temperatures, right? Isn't that what we said the other day? Typically, temperatures kind of go in a periodic function, right? Because on average, it's going to be roughly the same, at least for a certain amount of days, right? It may not be, obviously, it's not going to be like that for an extended amount of time, but you know, we're looking at, say, July in the Rio Grande Valley. It's probably going to be a high of 107, and it's probably going to be a low of 81, right? At least for 4 or 5 days straight, right? You might have a little fluctuation, but roughly that's what it's going to look like. Okay. So 6.4, y'all, talks about translations of the graphs of sine and cosine function. We're going to talk about something called phase shift, y'all. So what we're going to be doing, we're going to be looking at the same graphs, okay? But from your perspective, we're going to be moving those graphs either to the left or we're going to be moving those graphs to the right along the x-axis. So we're just going to take it, we're going to kind of shift it over this way, or we're going to kind of push it over that way, okay? So there's a couple of things that are going to go on here, y'all. And I'm going to remind you guys of a couple of things. I don't know if you might remember this from last semester, college algebra, but when we have something that looks like this and something that looks like that. Okay, y'all, I want you to notice from my typical function that we have, y equals f of x, right? That's our typical function, y equals f of x. Y'all, we changed something in both of those cases, right? Do you see how where the change is occurring inside my parentheses, right? Because it's f of x minus d or it's f of x plus d. That's inside my parentheses. Y'all, when we're making those changes, those are making changes horizontally on the x-axis, okay? So because I'm changing my x values, right? Now, contrary to what we typically like, it's intuitive. We normally think if there's a minus, we're going to the left. Y'all, we're actually going to the right. Okay, it's kind of counterintuitive. Normally we would say, hey, if you're minusing, aren't I going this way? We're actually not. Excuse me, we're moving to the right. If it's a plus, that's when we move to the left. Okay. All right, this is what we're going to do, y'all. We're going to figure out how do we graph something that has a phase shift. Okay, so the first thing I'm going to do here, y'all, I'm going to look at this function here, all right? I'm looking at y equals the sine of x minus pi over 3, okay? Now, my question to you guys, if it's a minus, do you think we're going to the left or to the right? What do you think? If it's a minus, we're going to the right, okay? Y'all, we're going to the right pi over 3. So this is what I'm going to do, y'all. Right here, I'm going to go pi over 3. That's where we're going to start. Okay, y'all, remember our period is 2 pi over b? The b would be whatever number is in front of those parentheses. Y'all, the number in front of those parentheses, isn't it really a 1 because there's nothing there? So my period, y'all, 2 pi over 1, same thing as 2 pi. What I need to do, my friends, is I need to figure out where is that going to end, okay? So look, y'all, this is what I'm going to do. The way I'm going to find that point, sorry. Okay, the way I'm going to find that value right there, I'm going to take pi over 3, and I'm going to add 2 pi to it. I'm going to think of that as 2 pi over 1. So let's see, pi over 3. Y'all, I'm going to make that into a 3 by multiplying that by 3, multiplying by 3. That should be a 6 pi over 3. You guys agree this is going to be a 7 pi over 3? Okay, now, y'all, just like we did before, boom, I want to find my number in the middle. Okay, let's find our number in the middle. Remember, y'all, the way we're going to find the number in the middle, we're going to take this number and that number, we're going to add them together. Does anybody know what pi over 3 plus 7 pi over 3 would be? I'll give you a hint. The number in front of that pi is really a 1. If we were to add this number and that number, what would we come up with? I'll give you a hint. It's going to be over 3. What do you think pi over 3 plus 7 pi over 3 is? 8 pi over 3. Good. Boom. Remember what we got to do now, y'all? We got to find half of it. Okay. If we find half of it, wouldn't that be 4 pi over 3? Boom. There we go. Okay. Now, y'all, let's do the same thing again. Let's see if we can find this number right here and that number right there. Okay. So look, y'all, the way I'm going to find this one, 1 pi over 3 plus 4 pi over 3, that's going to give me 5 pi over 3, but I got to take half of that. Hey, Omar, that's 5 pi over 6. Okay, boom, there we go. Okay, we're almost done, y'all. Look, we're going to take 4 pi over 3 plus 7 pi over 3. That's going to give me 11 pi over 3, but I got to take half of that. That's going to give me 11 pi over 6. You see the game I'm playing? Okay. So I got to do a little bit of scratch work here, y'all. Okay. I got to do a little bit of scratch work. Boom. I'm going to come back, my friends. I'm going to make a table again. Look, boom. Here's my X. Okay. Y'all, I'm going to put pi over 3, 5 pi over 6, 4 pi over 3, 11 pi over 6, 7 pi over 3. Okay. Now we're looking at X minus pi over 3. Yo, that's just going to give me my traditional pretty numbers. What I mean by my pretty numbers: 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay. Now, we're just finding, again, our y values. Over here, bless you. Over here, my y value we said was 0. Then we went up to 1. Then we went back down to 0. Then we went downstairs by my toes at -1. And we came back to 0. 1, -1. Y'all, the only thing I'm going to do now, boom, you start my graph and it just starts shifted over a little bit, but we're able to figure out those numbers. All right, let's take a look, y'all. Let's see what else we got here in 6.4. Or is this 6.5? 6.4, I think. Yeah, 6.4. Okay, let's see if we can do this one here. We're going to do the same thing. Y'all, I'm going to try to do a little bit of scratch work on the side just so I know where I'm going to be starting off with, okay? So first thing we're going to do, we're looking at our function y equals 3 cosine of x plus pi over 4. Okay, first thing, y'all, if it's a plus pi over 4, do you think we're moving to the left or do you think we're moving to the right? We're moving to the left, right? Okay, look, y'all, if we're moving to the left right here, boom, that is a negative pi over 4, okay? Y'all, I want to know where are we going to end? So my period is still 2 pi, okay? And sometimes you'll ask me, Omar, how do I know my period is 2 pi? There's nothing in front of those parentheses. That means that the number in front of those parentheses, is really 1. So I'm just taking 2 pi divided by 1 is still 2 pi, okay? So y'all, I'm going to take 2 pi over 1 and I'm going to add or subtract pi over 4. Okay, let's do this. Oh, we got to make that an 8 pi over 4. Isn't this going to be a 7 pi over 4, y'all? Boom. Okay. Let's see if we can find the number that's going to be right there in the middle. We're going to take these two numbers, we're going to add them together, and we're going to find half of that. Okay, so look, y'all, 7 pi over 4 minus pi over 4 should be a 6 pi over 4, or we can reduce that to a 3 pi over 2, but I still got to take half of that. So this number right here, y'all, becomes a 3 pi over 4. All right, let's find the number that's going to be right about there in the middle between those two. Okay. So look, y'all, I'm going to add those two numbers together, the negative pi over 4 and 3 pi over 4, and we're going to take half of that. So negative pi over 4 and 3 pi over 4 should be something like 2 pi over 4, which is pi over 2, but I got to take half of that. Isn't that a pi over 4? Am I doing okay so far? All right. Y'all, let's add these guys together and find half of that. 3 pi and 7 pi, 10 pi over 4, which is the same thing as 5 pi over 2. But if we take half of that, isn't that a 5 pi over 4? Okay, boom, there are my numbers. Okay. Now, so again, y'all, you can see I got a little bit of scratch work to do. So if you need to do it on the side, hey, do it on the side, right? Look, y'all, this is what I'm going to do now. I'm going to come back over here. Let me grab this guy. Boom. Let's do a new one here. Boom. And let's do a little snip and sketch. Boom, like that. Okay. So y'all, what I'm going to do now is this. I'm going to come back over here and I'm going to make like a little table per se. Okay. My table is going to look like this. So we got negative pi over 4, pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Okay. And y'all, I want to say that we had inside our parentheses x plus pi over 4. These are just those, those nice pretty numbers like pi, 3 pi over 2, and 2 pi. And then, y'all, we're looking at the cosine of each of those pretty numbers, right? And didn't we say the cosine of 0 was 1? The cosine of pi over 2 was 0. The cosine of pi was -1, back to 0, back to 1, right? So y'all, what I'm going to do here, is these are going to be, right here. These are going to be now my y values, right? I'm just going to go in 1, 0, -1, 0, 1, right? So we're going to come back here and we're going to say, look, suppose that's 1, that's -1. So we start here, 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 and here. Boom. And we're done. Okie dokie artichokes. All right, y'all, let's take a look at example 3. And again, I'm going to try to go really slow here, y'all, to make sure that we're all good. Okay, and guys, I'm going to do some work on the side just because there's going to be some scratch work that I'm going to have to do. If you look at this problem here, you can see like, hey, there's a lot of stuff going on in this problem, right? So let's go slow. Y'all, I'm going to do it like this. Boom. Let's get a new picture here. And let's do this. Okay. And let's go like this. Okay. So we're going to do a couple of things. Number one, I'm going to take my equation, y equals -2 cosine of 3x plus pi. Y'all, what we need to make sure of when we're doing these types of problems is that the coefficient inside my parentheses, the number in front of my x, y'all, needs to be the number 1. And right now it's not the number 1. What number is it? It's a 3. Okay, we're going to do this, y'all. We're going to do a little bit of work. We, my friends, are going to factor out the number 3. Remember what factoring means. Factoring means we're really just dividing. Okay, let's go slow. If you take 3x and you divide it by 3, everybody agree we just get x? But we got to do the same thing over here. So if we take that pi and divide it by 3, pi over 3. Okay. Okay, couple of things, y'all. Number one, we want to figure out what is our period. And number two, we want to figure out, are we doing a shift to the left or are we doing a shift to the right? Okay, so let's look at this right here. If I see a plus, are we going to the left or to the right? To the left. Okay, so first thing I'm going to do, y'all, we're going to say, look, we're going to go to the left, pi over 3. Right here, y'all, boom, negative, excuse me, pi over 3. Okay, let's find our period. Y'all remember, the period is always 2 pi over b. Y'all, just to give you a heads up, that number right there, that number in front of those parentheses, that's my b. So my period is really 2 pi over 3, okay? What does that mean? It means that the distance from here to some point, that distance is going to be a distance of 2 pi over 3. We're going to find where we end by taking our starting point, negative pi over 3, and we're going to add the period to it, which is 2 pi over 3. Okay, y'all, if I add those two numbers together, I want to say we're going to get what, pi over 3? And then we got to take, I'm sorry, and this is where we're going to end, pi over 3. Y'all, I'm going to fix this a little bit so it's a little bit more even, because look, if that's a pi over 3, oops, sorry, then about halfway that way is got to be negative pi over 3, right? So I'm just trying to fix that there. Okay, y'all, what do you think the number in the middle is? Anybody know what the number in the middle is? 0, right? You can just look at it and say it's 0. But you can also say, look, negative pi over 3 plus pi over 3. Add them together, you get 0. What's half of 0? Still 0. Okay, let's find the other pretty points, my friends. Let's find this guy right here, bless you, and that guy right there. Y'all, one thing you can do to make some of this a little easier is use a little bit of number sense. I know there's a pi, but think about that as 1/3. And this number is 0. What is half of 1/3? 1/6. So wouldn't this be pi over 6? Robert, what would this one be? Boom. Number sense. Okay, let's do this, y'all. Pi over 6, negative pi over 6, right? Okay, y'all, we're going to play a game now. Boom. We're going to come back here. We're going to make a table. Okay. Negative pi over 3, pi over 6, 0, pi over 6, pi over 3. I'm going to look at, let's see, this guy right here. 3 parentheses x plus pi over 3. Y'all, this is going to give me those real pretty numbers that we always talked about. 0, pi over 2, pi, 3 pi over 2, 2 pi. Down here, we're going to make one more. Should have given myself some more room. It's all right. We'll figure it out. Boom. Okay. Let's see. We're talking about cosine, y'all. So again, when we're talking about cosine, bless you, we're talking about cosine. Remember, we're thinking about the x values. So wouldn't this guy right here, let's go like this. Wouldn't that guy be a 1, a 0, a -1, a 0, and a back to a 1? Okay. Y'all, I want you to notice, what do we have in front of that cosine? We got something in front of the cosine in our original problem. We got a -2. Okay, all we're going to do, I would actually write out -2 cosine of 3, but I ran out of room, so I'm just going to put -2 times. Why? Because all I'm going to do now, my friends, is take each of those numbers right there and multiply each of them by -2. -2, 0, +2, 0, and -2. So look, y'all, I'm going to go 1 and 2, 1 and 2. Okay. And so down here, we were at -2, 0, +2, 0, -2. That's all we got to do. All right. So y'all, let's see what else we got here in, that was example 3. Let's see what else we got here in 6.4, okay? All right. So y'all, I'm doing the same type of thing here. And again, I'm going to go really slow with this problem, y'all, because I want to make sure that I'm able to draw my picture out, okay? Now, y'all, one thing I want you to notice, we're also going to talk about vertical translations, okay? So y'all, again, typically when we have a function, we think of our function like this, y equals f of x. Now, y'all, we're going to, and again, this is something that you guys did last semester in college algebra, but I just want to remind you of a couple of things, okay? If you notice what I have right here, y'all, okay, we have made a change to our original function. Our original function was y equals f of x. Now we have either a plus c or a minus c. Guys, I'm going to ask you a question. Is that plus or minus c, is that inside my parentheses or is that outside? Outside my parentheses. Okay, guys. Yeah, when it's inside, you change from the x values. Because if you change the input, it was f of x plus c or x minus c. So we made changes like this. If the plus or minus is on the outside, y'all, we're changing the y values. This is more intuitive. If we got a plus, we're going up. If we got a minus, we're going down. Okay. All right. Let's see what we can do here, y'all. I'm going to do some scratch work just like we did before. So I'm going to copy this dude right here. And we're going to do a little scratch work. Okay. So first thing I want to do is I want to find our period. So let me write this guy out. Let's come back this way. Let's make that a little smaller. Let's get rid of this. Let's come back one more time. All right. Maybe not that small. Okay, y equals 3 minus 2 cosine of 3x. Okay, guys, first thing I want you to notice, we're not doing any horizontal shifting. We're not moving to the left, right, because we don't have any parentheses, x plus, x minus, anything like that. So let's first find our period. Remember, the period, y'all, is always 2 pi over b. The number in front of my x is my b. So our period should be 2 pi over 3. Okay, I'm just going to set up a couple of things here, y'all. So since there's no shifting, we're going to start at 0. We're going to end at 2 pi over 3, okay? Let's see if we can find those nice, pretty numbers that we've been talking about, okay? Y'all, between 0 and 2 pi over 3, again, let's use some number sense. Let's drop the pi just because it's one extra component that sometimes throws us off. Y'all, if this is 0, think about that as 2/3. What number is halfway between 0 and 2/3? Wouldn't it be 1/3? So can I think about it like that? Pi over 3? Okay, y'all, we did this part a little while ago. Again, let's think about that, right? Y'all, think about this. I know it's pi, but just think about it as 1/3. What is halfway between 0 and 1/3? 1 over 6, right? Boom. Good job, y'all. So that's going to be pi over 6. Okay. All right, let's do the hard one. Let's see what is between 1/3 and 2/3. So y'all, if I took 1/3 and 2/3 and I added them together, I would really get, or if I added those guys together, I'd really get 3 pi over 3, which is just pi. But what's half of that? Pi over 2, right? Does that make sense? Okay. All righty. So y'all, this is what I'm going to do. I'm going to take this, boom, and drop it down over here. Okay, so look, we had 0, and let's see, 2 pi over 3. Okay, so right here, I'm going to put it 2 pi over 3. We had a pi over 3. We had a pi over 6. We had a pi over 2, like that. Okay, so I'm getting that part done. Let's start to make our table, my friends. Boom. Okay. My x values are 0, pi over 6, pi over 3, pi over 2, 2 pi over 3. Since we're looking at this function that we have here, y'all, I'm actually going to think about this as a 3x, and that just gives me the nice, pretty numbers that we know and love. Okay, and then I'm going to ask myself, hey, Omar, do you know those cosine values of all the pretty numbers that we know and love? I'm going to say, yeah. 1, 0, -1, 0, and 1. Okay. All righty, boom. But I want you to notice what we have in front of our problem. We got a -2. Okay. So we're going to do this. We're going to take each of those numbers now, y'all, and we're going to multiply each of them by -2. That becomes a -2. That becomes a 0, +2, 0, and -2. All right. One last step here, y'all. My last step. What kind of 3 is that? Is that a +3 or a -3? That's a +3. Y'all, normally I would write out more, but I'm just going to write a +3 because I ran out of room again. I have a habit of not giving myself enough. Okay, let's add 3 to each of those numbers. 3 plus -2 is 1. 3 plus 0 is 3. 3 plus 2 is 5. 3 and +1. Okay, so look, y'all, 1, 3, 5, 3, 1. Come back over here, and I'm going to go 1, 2, 3, 4, 5. Okay, we had 1, we had 3, we had 5, we had 3. I didn't do it as pretty as I wanted to, so I'm going to make it a little bit prettier, hopefully. Okay, 1, 3, 5, 3, and 1. Here we go. Boom, boom, boom. There's my picture. Right. Y'all, I want you to notice a couple of things. In my picture, do you see how we have that 3? You can think you could do it like this too if you wanted to, y'all. You could think of that problem like this. Put the 3 at the end where it's a +3. Okay. What that 3 is, y'all, it's kind of this horizontal line right here. Okay. Remember when we talked about something that we called the amplitude of the function, y'all? The amplitude of the function says, kind of like from this middle point, how far do you got to move up to hit the top part of your function? So y'all, if I'm right here at 3 and that's 5, how far do I have to move up? 2 spaces, right? So look, y'all, we're going to say that our amplitude is equal to 2. Now, just to show you a couple of things, y'all, from looking at the equation, there's an easy way to find the amplitude. The easy way to find the amplitude, y'all, is if you look at this function right here, the amplitude is always going to be equal to the absolute value of A. That's my A number. So the absolute value of -2 is just 2. Does that make sense? The amplitude says, look, from the middle, how far down do you got to move till you hit your low point? It's asking you for a distance. Y'all, distance is never negative. If I said, look, from where I'm sitting all the way over here to where Joanna's sitting all the way over there, y'all, suppose we said that looks like it's about 22 feet from me to Joanna. How far would you say from Joanna to me is? Still 22 feet, right? Distance is never going to be negative. Does that make sense, right? Okay, good, good, good. All right, guys, I'm going to scroll down again. And we got a couple more problems to do. So, y'all, there's a couple of things we're going to do here. All right. I'm not a big fan of going through method 2. I'm a bigger fan of going through method 1. So number 1, it says, can we find an interval whose length is 1 period of 2 pi over b by solving the 3-part inequality? I'm going to walk you through this, y'all, right now so we can figure out what it is we got to do. Okay. All right. Question. Yeah, go ahead. So the way we're going to find our the interval length from where we start to where we end, we're going to solve that inequality. We'll do that in a second, okay? We've kind of been doing that so far, but we're going to do it in a second. We're going to cut that interval into 4 equal parts to obtain those 5 key x values. We're going to evaluate our functions. We're going to find our amplitude, and that's pretty much it. Guys, I know some of the problems say draw it over 2 periods. I don't think it's necessary to do that. I think once you have 1 period, you know what the other one looks like because it just kind of continues, okay? That's the whole point of periodic functions, all right? So look, let's try a problem like this one here. All right, so y'all, step number 1, I'm going to rewrite my equation. I'm going to write it like this. Y equals -1 plus the sine of, y'all, I want to make sure that the number in front of my x inside my parentheses is a 1. Right now it's not. So I'm going to factor out that 4. When we factor out that 4, remember what it is we're essentially doing, y'all. We are dividing everything inside my parentheses by a 4. So 4x divided by 4, just an x. Pi divided by 4, pi over 4. Okay. Okay, guys, we can do this whole period thing, but we can also find the starting point and the ending point. Let me show you how I'm going to do that, y'all. I'm going to take this guy right here. That guy right there, y'all, normally goes between 0 and 2 pi. And actually, you know what? Let's do this real quick, y'all. Sorry, let's do this. Oops, my bad. Let's take what we originally had. I know we did that whole inequality business, but let's do this. Let's do it this way first. I think it'll make the calculation easier. That guy has to be normally between 0 and 2 pi because that's what our trig functions look like. You have a period between 0 and 2 pi. Let's solve that inequality. Y'all, if I were to go minus pi, minus pi, minus pi here, we'd end up with a negative pi less than or equal to 4x less than or equal to positive pi. Next step, y'all, we got to divide everything by what number? By 4, right? Boom, let's divide everything by 4. Let's divide everything by 4. Let's divide everything by 4. Okay. Look, y'all, we're going to start at negative pi over 4. We're going to bigger so that it looks nice and neat. Okay. I'm going to go right here. Negative pi over 4 and about halfway that way. That looks about right. Pi over 4. Okay, we're going to find our key x values. Guys, what would be the number in the middle? 0. Boom, there's that one. Okay, let's see if we can find those two. Think about this again as 1/4. What's half the distance between 0 and 1/4? Or what's half of 1/4? Wouldn't it be over 8, right? Okay. And then wouldn't this one over here be also over 8? Okay. Those are my 5 key points. Look, y'all, we're going to come back here now. We're going to make our, we're going to go like this, x. Okay. So we had negative pi over 4, negative pi over 8, 0, pi over 8, pi over 4. Okay. All right. We had something like, guys, you can write it either way you want. You can either write it with a 4 on the outside or you can leave it as it is. I'm going to write it with a 4 on the outside because I think that's typically what they write. That's just going to give me those nice, pretty numbers that we all know and love. So what I mean by those nice, pretty numbers that we all know and love, 0, pi over 2, pi, 3 pi over 2, 2 pi. Okay. All right. Let's do this. What was our original function? Okay, look, y'all, we had a 2 sign. Okay. So first thing I'm going to do, I'm going to go ahead and just rewrite it here with a sign of 4x plus pi over 4. Okay. And I'm going to fill in those nice, pretty numbers that I know and love. So what I mean by that, the sign of 0 is 0. Sign of pi over 2 is 1. This is 0. This is negative 1 back to 0. Okay. What did we have in front of it? Oh, we had a 2. Okay. So I'm now going to put, a 2 sign of 4x plus pi over 4. And I'm just going to take those numbers that we had before, y'all, and I'm going to double them. So 0 times 2, still 0, still 2, 0, negative 2, and 0. And then one last part, y'all. We got one last thing here at the end. We have a minus 1. Okay. So, y'all, all I'm going to do now is from each of those numbers, my friends, I'm going to subtract 1 out of each of those numbers. 0 minus 1, negative 1. 2 minus 1, 1. Negative 1. Minus 2 minus 1 more, negative 3. And negative 1 right here. Okay, y'all, it looks like we have a low point of negative 3 and a high point of 1. So I'm going to do something like this, y'all. I'm going to go 1, okay, negative 1, negative 2, negative 3. Okay, so at negative pi over 4, y'all, I'm right here. And then we're going to go up to 1 right here. And then we're going to come back down to negative 1 down here, negative 3 right here, negative 1 like that. So my graph does something like this, right? Let me do it in red. So maybe it's a little easier to see. There we go. Does that make sense? Faith, am I doing okay? Okay, just checking with you. Guys, look at this line right here. Okay. Right here, guys, I'm at negative 1. Down here, we're at negative 3. Does anybody know what my amplitude is? Remember, how far is it from here to here, or how far is it from there to there? But remember, not negative, just what value? I'm sorry, say it again. Hold on. From negative 1 to positive 1, how far do we go? 2, right? Or from negative 1 to negative 3, we go 2. Guys, one more time, just to kind of show you something. How do I know what the amplitude is? Always the absolute value of that number right there. Now, so y'all, one thing I want to mention, in this case, it was a positive 2. And so you might think, hey, amplitude is positive 2 because that's the number in front. Even had that been a negative 2, the amplitude would still be positive 2. Because remember, y'all, the amplitude measures the distance. So if I said, how far is it from where I'm sitting to where Joanna's sitting? We said it's 22 feet. How far is it back? It's still 22 feet. So absolute value, guys, never going to be a negative number. Okay. Let's see. Okay, guys, we're going to skip this last one here. I'm going to get you guys the homework for today, which is the 6-3. And I'm going to go through just part of it to kind of give you a heads up of what it is we're kind of looking at here. Let's see. Let me give you 6-4. That's the one we got. And guys, I graded your homeworks from the other day. I'll get those to you right now too. anybody see Cole outside of us? Does anybody see Cole tomorrow? Tomorrow? I'm gonna give you an extra, if you don't mind, give it to me. So he's got it. And guys, I'll get you your homework right now too. Let me do this first. What I want to do, y'all, I want to work out problem number 2 with you guys from the homework. Okay, so let me do this real quick. Boom, let's come back this way. Let's stop recording. We don't need it. And we can leave the session.